Anyway, welcome to Drydock episode 28, the episode where you get to find out who won the competition in Drydock episode 25, because apparently either I'm really bad at communicating with people via YouTube messaging, or most people don't pay attention to their YouTube messages. It could be a combination of both, to be honest. Anyways, if the following winners taken from the comments thread in the episode in question, in the pinned post reply section, if you could get in contact with me at 5minuteguides@gmail.com, that would be most appreciated, so I can work out how I'm supposed to actually get your prize to you. Those people are Peter I. Zabo, I think, spelled Szabo with a little mark above it. So that's winner number 1. Winner number 2 is Stephen Friswell. Winner number 3 is David Stevens. Winner number 4 is Firewatch814. And winner number 5 is Odin Vic. And if I haven't heard from any of those people by the time it's time to broadcast Drydock episode 29, I'll have to choose new winners. Separately, I did notice a number of comments outside of the pinned post, and that was because apparently YouTube decided the pinned post had reached its maximum comment limit and wasn't letting anyone reply. So I decided to pick 2 additional winners from that section of the video. So 2 additional winners, and winner number 6, Clifford Adams, and winner number 7, Crimson Call. So if those 7 individuals would like to get in contact with me over the next week or so, you will have the opportunity to select one of the prizes mentioned way back in episode 25. Right, with all that said and done, time to go to the questions. Jerome McCarthy asks, how did refueling at sea work in the early 1900s? For example, how did the Russian fleet complete resupplies at sea during the Russo-Japanese War? Well, back then, refueling at sea was not a matter of pipes and hoses like it would be in the oil-fired period. It was coal. And coal is big, heavy, dirty, but fortunately can be carried in bags. So when you did have to resupply at sea, which you tried to avoid if at all humanly possible, there were 2 ways of doing it. The more common way being to simply draw 2 ships up alongside each other in a calm area like a inlet or natural harbour, or if you were really feeling lucky, a particularly calm day at sea, and you'd string a couple of gangplanks across, or maybe a small derrick crane or something of that nature, and the crew of one ship would bring coal up in sacks onto the deck, and it would be transferred by either crane, gangplank, or in some adventurous cases throwing, over to the other ship, where the crew would have to then pick up the coal and take it back down into their own coal bunkers. This was long, dangerous, and very tiring, and therefore not very popular. So the vast majority of resupply when you were out of port would take place in ports when at all possible. So this would be things like visiting port, basically, and buying coal in place, or as the Germans would do in World War One, purchasing coal on ships and having those ships sail to meet up in a port on a certain date. If the port itself either didn't have or wouldn't sell you coal, you could just do an internal transfer between the ships at the port facilities, which is obviously more stable than doing it at sea. Resupply at sea in terms of keeping a ship moving, as you can do with oil, was basically no. Just don't even think about it, no. It's not going to happen. So yeah, that is the general answer to how you resupply coal-fired ship at sea. Of course, the one advantage that this kind of resupply method and this type of fuel did have was that, unlike oil fuel, you didn't have to have complicated and bespoke systems for actually doing the resupply. You could, at worst, do it just with manpower, which meant that in World War One, it was much easier to resupply commerce raiders and the like from captured ships' fuel stocks. Don Felipe asks, the Portuguese maintained an overseas empire until the 1970s, and this probably required a navy to police various sea lanes. What did this navy consist of? Was it viable in terms of 20th century naval fleets, at least locally and in the short term? How likely was it that Brazil, a fellow Portuguese-speaking country, with their dreadnoughts, might have been involved in any Portuguese disputes? Well, To answer the second part of the question, the Brazilians were not especially likely to get involved in disputes involving Portugal and a third party. They went off on their own way independently, and they weren't particularly inclined to get back involved with Portugal in any major way. To be honest, if there was any party that was going to get involved in a dispute that involved Portugal and naval matters, it was probably going to be the UK. And that's not just because the UK tended to stick its nose in everywhere in naval matters in most of the 19th and early 20th centuries. It's also due to the fact that England and Portugal have the longest standing unbroken alliance in the world. So, yeah, the Royal Navy would be much more likely to step in on behalf of the Portuguese Navy than the Brazilian Navy would. In terms of its 20th century capability, the Portuguese Navy unfortunately was on a bit of a downward spiral. This was because effectively, although in most of the Age of Sail it had been a relatively high-ranking second-tier power, a rather nasty civil war in the early to mid 19th century had pretty much wrecked the Portuguese fleet, and what was left never really recovered its previous strength. At the start of the 20th century, they did have a rather nice balanced fleet for a smaller nation, with half a dozen cruisers and a bunch of destroyers. But the majority of the fleet, in terms of numbers, was actually made up of small patrol boats and gunships, useful for obviously keeping law and order around the colonies. So this was a nice, quite handy force, and they did take part in World War One against Germany, with a number of their ships seeing actions in various places. A lot in the colonies, where Portuguese colonies, when they bordered with German ones, took the offensive against the Germans, and a number of the core Portuguese Navy ships taking part in various landing actions and convoy escort duties and things like this. They were certainly in a much better shape at the turn of the 20th century than the Spanish Navy was, even pre-Spanish-American War, which I suppose is something for them to be proud of, albeit that they didn't have a battleship. They just, as I said, had cruisers, but one of their armoured cruisers was fairly nice for the time period that it had been built in. After that, after World War One, again, the Navy just went into a slow decline, mainly through just not getting enough funding. By the time of World War II, the Portuguese were supposedly neutral, leaning quite heavily towards the Allies, and at this point their fleet was more in the order of destroyers and light craft, with the odd exception. Really, there's a couple of larger destroyers that verged on the size of a light cruiser. Following World War II and the integration of Portugal into NATO, the Portuguese Navy underwent a bit of a renaissance. Its size didn't go up all that much, but it became much more focused and specialised in light amphibious warfare, counterinsurgency, and a lot of anti-submarine work. So it became a fairly specialised navy, especially in light of the NATO mission. They became pretty good at it, and that's pretty much where they've remained to this day. As I say, primarily a sort of a frigate-based anti-submarine warfare fleet. It's not the world's biggest navy by a long shot, but they've retained a lot of long-distance operational capability, which is surprising because it means that they can actually deploy significant amount of their navy quite a long way away overseas, which some larger navies actually can't. You'd be surprised some of the navies in the top 10 of the world actually have significantly less force projection capability than the Portuguese do, simply because they lack the fleet train to keep their ships supplied. But there you go. The fact that Portugal still technically retains its old alliance with the UK also helps, and they seem to get along quite well with the Royal Navy, from what I've heard. David Kaminsky asks, can you touch on the different types of steel used in ship construction, such as Harvey, Krupp, STS, etc.? When were they implemented, and what were the advantages of one over the other? So there is, as I mentioned in a previous Drydock, I believe, There are four types of steel used in the construction of a ship. You have your standard structural steel, you have your special structural steels. STS falls into this, and it's basically a toughened structural steel. Costs more to produce, but is stronger, as the name suggests. And it can, in some circumstances, approach the toughness and quality of low-grade homogeneous armor plate, but it is still a way off of that. So it cannot be counted as armor realistically. It can be counted as a slightly tougher strengthening aspect to the ship, but realistically, no one made STS plates in armor grade thicknesses, or any similar other special structural steel, especially when we're talking about battleship grade thicknesses. So there's that. Then you've got your homogeneous armor steels, and this is just basically a single piece of steel which is treated the same, hence it's homogeneous all the way through. They're basically good as a mass blockers, absorbing splinters and stuff like that, but from your question, mainly talking about Harvey and Krupp, I take it you're interested mostly in the armor steel. So after that very brief summation of steel, as a use in everything else, we'll talk a little bit more in depth about armor steel itself. Now, obviously, this is a brief history, as I do at some point plan to do a special video on it, but in brief, you had ironclads, which used hammered or rolled iron, depending on the level of technology of the nation and the time period, and this was backed by teak to prevent splinters. But obviously iron only has a certain strength beyond which it's not really going to go, and with the invention of the ability to produce steel in large enough amounts and shape it into large enough plates to be used as realistic armor, there was a brief period where people were just trying to use steel instead of iron, in just sort of one-for-one swap. And steel being stronger could obviously keep out more shot. However, to make it stronger and stronger and stronger, you also make it harder and harder and harder, which sounds great until you realize it also makes it more and more brittle, which is not good. And so you can end up with large cracks and shattering and huge bits of splinters breaking off on impact. And so in an effort to mitigate this, you had the development of what was called compound armor, which was basically you take your slab of incredibly hard but brittle steel, you take another slab of rather softer but far more ductile iron that's less likely to crack, you put them nearly next to each other, and then you pour molten metal between the two to kind of weld the two together. This creates, say, a compound armor that's basically a face of very hard steel and a back of very soft iron. And that is where armor sat for a little while until the invention of Harvey steel. So Harvey steel, which was the first single piece face hardened armor plate, it took the idea of compound armor and took it a little bit further. It introduced a few interesting trace elements, primarily nickel, into the steel, which changed its chemical and physical properties a little bit. But the main innovation was differential hardening. So this was basically where you would heat one side differently to the other, and then you would cool it differently to the other. Specifically, you would end up cooling the facing side, the side that faced outside of the ship, a lot faster, which created a very hard but brittle surface, and the back was cooled slower and then annealed further, so it retained a great degree of ductility, and therefore the whole armor plate wouldn't shatter, because even if the face cracked, the rear would hold it together. And this, as a single thickness, combined with the various, say, slight changes to the chemical formula of the steel, rendered Harvey steel significantly better at protection than compound steel. It was something like a 10 to 15% increase in defensive capability, and obviously much, much superior to iron plate. So a lot of the early pre-dreadnoughts would use Harvey steel armor, and ships of that era. And then this was obviated further towards the end of the 19th century by the advent of Krupp armor steel, which, as the name suggests, Harvey steel being invented in America by the Harvey Steel Corporation, Krupp armor steel being invented in Germany by the Krupp Arms Works. They weren't particularly original when it came to naming these things. The two major advances of Krupp armor were introduction of yet more trace elements, primarily chromium, as well as a much more advanced method of introducing carbon to the outer facing plate, which could then obviously combine with the trace elements to make an even harder faceplate. And this was using the progress of technology to use superheated gases rather than charcoal lying on top of the steel. So the Krupp steel gave another jump in improvement of it's about 20% more effective than Harvey steel. And now this steel was getting to be quite the alloy with obviously carbon, making it steel from as compared to iron, also nickel, which it adopted from the Harvey steel, chromium, manganese, and a bunch of other small trace elements. So Krupp steel was the general armor steel that went into the dreadnought era alongside everybody else's, and then you have a whole load of variants on that were developed by various countries, because at this point naval technology was becoming more and more of a closed shop, more and more of a state secret, and you would end up with multiple variants being produced. They were mostly competitive and largely dependent on the material quality of things like the iron ore present in the local country for the World War I period and into the early interwar period. And people play around a little bit with how deep the hardened face would be compared to the ductile backplate and things like this. And then independently in the interwar period, both the Germans and the British made and kept secret advances further in the chemical formula of the steel, introducing yet more exotic trace elements into the steel, primarily things like molybdenum, that would give the German and British face-hardened armour steels produced in the 30s and into World War II a advantage over the American and other armour steels, which remained slightly improved compared to the World War One steels, but nowhere near as well improved as British and German ones. And down at the bottom of the pile, you had the poor old Japanese who were stuck with the fact that Japanese iron ore quality is terrible. And as a result, with, well, base material is rubbish. It's not to say the Japanese armor was rubbish, it was still reasonable. But the quality gap between it and American plate, and then the quality gap between either of them and British and German plate, it was enough. It's enough that you have to run theoretical penetration tables for specific combinations, because you can't just take one test and go, oh well, X shell will penetrate Y inches of armor, therefore Z ship from another nation with so and so inches of armor will be penetrated. Because no, if you've got tests, if you're relying on tests where you've got a Japanese shell fired at a Japanese plate and then you take that same shell and fire it at a British or German plate, you might not go through. Conversely, if you take a shell test that was done by a British or German company that was firing at British or German in late interwar - World War II plate, and then you fire exactly the same gun at exactly the same range in exactly the same conditions, although that's fairly unlikely anyway, but let's say that you did, against an American or a Japanese plate or even an Italian plate, you actually would stand more of a chance of getting surprisingly good penetration values as compared to what you might expect from the homegrown tests. So yeah, that's a very brief history of naval armour, and as I said, I will try and cover this in a lot more detail because there's massive amounts that I've left out in that, because, well, let's face it, you're talking about 50 plus years of technological advancement in one of the most vital areas of battleship construction. There's no way I can cover that in a handful of minutes comprehensively. Type here asks, what stopped the Japanese from using a 3x3 gun turret arrangement on their heavy cruisers apart from possible speed? So that's 3 triples. This was broadly down to Japanese tactical thinking and the fact that the Japanese knew that they were almost certainly going to be outnumbered in any war. It's actually the same kind of tactical thinking that goes all the way back to the Fuso class, where they had the option to go with triples for their 14-inch guns, but they actually went with 6 twins. And the two parts to this were, one, that a hit that took out any individual turret would take out less of the main armament if you had the same number of guns in twins as opposed to in triples. But also the Japanese Navy took a very offensive mindset, thinking that they were going to be sort of charging out and engaging a numerically superior opponent, at which point having multiple twin turrets meant you could engage more individual targets at once. And once you started to get up to sort of 5 or 6 turrets, you could actually make reasonable engagements of at least 2 separate targets, possibly more. Whereas if you were using triples, you could direct 2 triples at one target and 1 at the other, but the single triple falls below that 4-gun threshold for accurate salvo firing that we mentioned, and so accuracy would suffer significantly. And those were basically the 2 main reasons they stuck with the twin arrangement for so long, both on battleships and on their cruisers, with really only the Yamato in their modern battleship characters actually having triples. The other smaller factor was the fact that they were desperately trying to cheat. A, trying to cheat on the Washington and London naval treaties, and B, get a very fast ship, and a triple turret requires a wider hull than a twin does. So, and obviously if you have more twins you make the hull longer, but hey, if you're trying to make a fast ship you want a long thin hull anyway. Obviously this did come back to bite them somewhat when you got ships that were hilariously underbuilt for the weather, and on certain lighter ships you obviously just need to go with triples, because if you try and make a ship that's got 15 6-inch guns, well, 14 or 16 6-inch guns, you put them all in twins, it's just going to be stupid. So things, when you get to 6-inch guns and below, they start heading back towards triples. But yeah, heavy caliber guns, 8-inch and battleship grade, generally twin turrets for these reasons. Zombie Hero 14 asks, in some early dreadnoughts, the super-firing turrets firing directly ahead or astern would cause the gun crews in the turrets below to suffer blast effects. What caused this, and what was done in later designs to solve this problem? So this was caused by something of a throwback to earlier design decisions that were held over into the dreadnought era. Basically, in any dreadnought you have your central fire control, which is one of the key aspects of a dreadnought, is the sort of central fire control for all the big guns. However, it was recognised, and various ships in various battles did find, that having a central fire control system meant that 1 or 2 lucky hits could take out your entire method of controlling your guns for elevation, range, target bearing, etc. This is obviously a bad thing. So how do you solve that? Well, you solve that by having each turret able to independently fire if possible, and you also install secondary rangefinders and fire control centres. But rangefinders and fire control units are pretty big, hefty things, especially if you're going to mount them high enough up in the ship to have any noticeable effect. So you don't scatter them all over your ship. It's a limited amount, and obviously if you lose, even if you lose communications cables, you could end up with your turrets having to sort themselves out. So then how does a turret sort itself out? Well, later on, when you look at various turrets, you'll notice they appear to have sort of little ears sticking out at the back at either side, and these are rangefinders. They can be completely enclosed and therefore shield people from blast effects. However, in the pre-dreadnought era, when you didn't have to worry about super-firing turrets, and rangefinders weren't either as big or as seen as needed so much, since you're pretty much firing at point blank range, turrets tended to come with what were called sighting hoods, which, as the name suggests, are sort of a little armoured hood on top of the turret, which you have 1 or 2 of, and these would allow crewmen to basically stick their head up and go, I wonder what I can see, whilst hopefully being at relatively minimal risk. These, as obviously then, are open into the turret, which is fine if you're in a pre-dreadnought type ship where your turret is the only big gun on the block on that end of the ship. But when you have a gun turret super firing above and the gun fires directly over the lower gun, or in the vicinity of, all the blast wave and blast effects from the upper gun turret can have a nasty habit of travelling through those open sighting hoods and into the lower turret. So then you end up with obviously the lower turret suffering quite severe blast effect as a result of that. This problem was solved basically by closing off the sighting hoods, because as the director firing control systems got better and better and ranges moved further and further out, they were essentially pointless, because if you were so close to an enemy ship that you could even use a sighting hood as an accurate method of fire control, you were already in a lot more problems than a sighting hood was ever going to solve. And this, combined with the introduction of installed rangefinders on turrets, which didn't require openings to the air, meant that the sighting hoods were phased out and the blast damage issues went away with them. The new IKB 4472 asks, naval guns larger than 18 inches, were there any planned, developed or tested, and how useful would a 20-inch gun actually be? Well, in answer to planned, developed and tested, yes, two nations did that. The Japanese did apparently actually build a few of the 20.1 inch or 510mm guns that they were planning to arm the Super Yamato classes with, but we have no real idea as to what they actually did with them. They may have tested them, they may not have, and they probably destroyed them to keep them secret at the end of the war. But as I covered in the video on the Yamatos, the Japanese basically burnt almost everything they could find to do with the project, so all we actually know is a few existed and they may or may not have tested them, and that's about it. The other one was Germany, because somebody decided that obviously the ridiculousness of the later H-class designs would need stupidly large guns. Again, not a lot is known other than a gun was manufactured, and according to some reports they even tried firing it a few times. This was a 21-inch gun or 530mm gun, but again, not a tremendous amount known beyond that. In terms of practicality, basically forget it. Even the Super Yamatos, the A150s, they were even bigger, as the name suggests, and even they could only fit 3 twin turrets for 6 guns. It's just not practical. The sheer size and weight of the shell and the size and weight of the guns mean that their rate of fire is going to be significantly less than an 18-inch gun, and no battleship in history was ever designed to be able to withstand that kind of firepower. But by the same dint, to be honest, at the kind of practical battle ranges that existed, no battleship in history was designed to stand up to an 18-inch shell either. So you might as well just go with an 18-inch shell and give yourself more guns, because you can give yourself 3 per turret instead of 2 per turret for roughly the same weight, get a slightly higher rate of fire, and obviously with more guns and a slightly higher rate of fire, you're going to hit the enemy sooner, and you're going to therefore do a lot more damage to them. So yeah, people tried, but practically speaking, no. I mean, realistically, you probably want something in the 16 to 16.5-inch range as your ideal gun for any kind of practical battleship. You could go with an 18-inch if you want to sort of push a ship up to 60 to 70,000 tons plus. But no one ever really did that, apart from obviously the Japanese. So yeah, 18-inch I'd say is probably pushing it as far as the limits of practical battleship gunnery go. There's nothing really that a 20-inch offers you that an 18-inch doesn't. Donald Palmrose asks, being a US Navy surface warfare officer at one time and an engineer interested in naval engineering history, I'm wondering how much you credit the innovations from the US Civil War in influencing British warship design. To be perfectly honest, although the US Civil War was a very large and active war zone by any definition of the word, their naval innovations that affected people elsewhere were not exactly what you might imagine. They demonstrated the effectiveness of the spar torpedo, and they revived interest in submarines. and semi-submersibles and that sort of thing, definitely. They also demonstrated the utility of minefields and made major advances in the designs of shore fortifications. But in terms of things like armour and naval guns and ship design, which is mostly what people would think of when it comes to naval technology, they didn't make that much of an impression on everybody else. And that was primarily because at this point, although the US had a fair amount of industry, it was still nothing like what it would be in the 20th century. And also, technologically speaking, the American Navy was, well, the American industry, and therefore what they could supply to the American Navy, was a little bit behind the curve on a lot of European ships and shipyards. So, for example, with armour, at a time when the British and the French were rolling multiple inch thick single sheet pieces of iron for armour protection, the Americans were having to make do with laminated armour put together from some fairly poorly made iron and then just sandwiched together in ridiculous thicknesses to try and make up for the weakness of laminated armour and the weakness of the material itself. Similarly, with the guns, the Americans did go very big, and they demonstrated that very large caliber naval rifles were a thing that could be done. I mean, obviously you had things like the Dahlgrens going up to 15 inches by the mid to late American Civil War period. The flip side to this was that the Dahlgren guns were, in naval terms, relatively speaking, large, low velocity weapons, better for smashing than they were for armour penetration, as was ironically somewhat well proved in the various monitor versus monitor engagements. Obviously, things like Virginia versus Monitor being a classic example. And yeah, so they demonstrated the utility of having some large low velocity smasher guns as effective against wooden warships, very definitely. But obviously, both sides, ironclads, demonstrated that when they took on the other side's wooden craft. But as guns for use against other armoured ships, not so much, really. And most of the ironclads that were built, if you use ironclad as a general catch-all term for a ship armoured with iron plate at the time, were monitors, and with the exception of a few of the last ones, they were all riverine or coastal units, which nobody was particularly impressed with at a time when the European nations were churning out ocean-going ironclads. Although some of the later ocean-going monitors was looked at with a degree of interest, to be fair. And the two larger ships that the Union Navy produced, Galena, the less said about it, the better. And New Ironsides was actually a pretty good, creditable ironclad frigate design. It's just unfortunate they didn't build more than one. That is a bit of a shame. I like New Ironsides. It's not quite as good as Warrior, but I do still like it. Certainly beat the pants off Gloire, to tell you that much. So yeah, basically to sum up that little bit of rambling, I would say the technological advances and tactical proofs of concept brought about by the American Civil War were more in the field of ancillary naval warfare items, such as I said, mines, torpedoes, submersibles, the effectiveness of small ironclads, both of a monitor type and not in coastal defence, and with use against wooden warships, very definitely. The utility of very big guns in certain situations, but if you want to sort of look at what you would consider the cutting edge of naval warfare, i.e. ironclad versus ironclad engagements, the US Civil War didn't offer that much in those terms, other than don't build an ironclad in a lightweight fashion like the Galena, because that's a very easy way to lose a ship. And on to the Discord questions. Turtleman247 asks, was there any real reason behind the different shapes and evolutions of the smokestacks on ships through the 1930s and 40s? For example, the Japanese smokestacks being connected at an angle. Yes, and this was largely an artifact of the naval treaties where ships previously would have been scrapped, they had to be refitted and modernised. And where they were refitted and modernised, that generally involved changes both to the superstructure and the boilers. In terms of the superstructure, there was a lot more equipment and a lot more stations that required platforms and such above the main deck, and usually well above the bridge as well, in terms of things like rangefinders, aerial gunfire control stations for the anti-aircraft armament and such like. And all of these began to rapidly crowd, sort of, if you like, the airspace above the ship's hull. Various navies had different solutions to this. Obviously the American Navy had this kind of slightly pyramidal type superstructure. The Royal Navy said, "Screw it, we're just putting effectively a tower block on our ships." The Japanese went and built the pagoda masts, and so on and so forth. And all of this meant that all of a sudden, having a bit of smoke up near the upper echelons of your superstructure was a lot more of a problem than it had been in the past. So, in some cases, forward funnels got trunked back to join rear funnels, and to basically just get the smoke away from the forward superstructure so that these new bits of equipment and stations could operate without being lightly kippered. And at the same time, when the ships had bigger and deeper refits, you quite often would have the same or similar amount of power generated by much fewer boilers, which took up a lot less space, which then meant you didn't need either as many or any additional smokestacks beyond the one. And so you got a lot of sort of multi-smokestack ships would have the funnels consolidated into a single large funnel, and where these funnels were quite far apart, it was worth taking the funnel out completely, plating over the hole, using the deck space for something else. But where you maybe had two smaller funnels that were quite close together, it was easier just to trunk the two funnels together into one and call it a day at that. So yeah, it led to a whole series of weird shapes and sizes and trunkings on funnels, but that's the broad outline of why you have so many of this type of thing going on in the interwar period. Turret Welder asks, what World War II Navy had the best anti-aircraft guns? Well, I think the star of the show, as far as naval anti-aircraft guns go, has to be the Bofors 40mm. At which point the answer is the Allied navies, because basically every Allied navy got their hands on them, and occasionally even the Axis navies got their hands on a few of them as well. But no, if you want to talk about overall best naval anti-aircraft guns, then as a gun, it's you can't really just say best naval anti-aircraft guns, because you had like the German 88mm, fantastic naval anti-aircraft gun. Pity about the rest of the systems on most of the German warships that rendered them somewhat less effective. You have to look at the entire system, and this includes things like, what are you using to spot? Are you using radar? Are you using a good fire control system for your anti-aircraft guns that links the radar feed to the anti-aircraft guns output? Are you using powered turning mounts for the AA guns? What kind of sights are you using? And all this. So taking all that into account and sort of bringing up a gestalt, somewhat unsurprisingly, it's quite easily hands down to the United States Navy. They had the Mark 37, they had radar, good radar, they had the 5-inch 38 caliber gun, albeit that the slightly shorter one was actually a better AA gun, but the 5-inch 38 was no slouch at all by itself. And of course, they had the standard issue Bofors 40mm and 20mm Oerlikon, although the 20mm Oerlikon was being replaced by more 40mm by the end of the war. So put that all together, and the best overall AA gun fit in any Navy has to go to the US Navy. If you want to look at very specific guns, then things get a lot more interesting, because the French had some fairly nice medium caliber AA guns. Surprisingly enough, the Italians actually had some pretty decent medium AA caliber guns as well. And when you go right to the end of the war, if you want to look at the Bofors 40mm, the British actually invented probably what were arguably the best mounts for the 40mm AA gun, which dramatically improved their performance when taken as a single unit. Albeit that one of the best mounts they had was kind of stolen from a Dutch ship that managed to escape from the Germans, but never mind. The less said, the better. Um, but yeah, so yeah, if you want to look at individual AA guns in isolation, pick a number, any number almost, as long as it's not French or Japanese. Um, but overall, systems-wise and overall, it's got to be the Americans. Z46 asks, what were the three biggest destroyers by tonnage in World War II? Okay, well, it may come as a little bit of a surprise to some, but maybe not to others, that the top of the tree, this particular tree, is in fact a French ship, with the Mogador class rolling in at a comfortable 4,000 tons fully loaded. So yeah, that's one heck of a big destroyer. The Germans, unsurprisingly, are coming in at a nice second with the 3,700 ton maximum displacement of the Type 1936A destroyers, which is matched actually by the Akizuki class of Japanese destroyers, also at 3,700 tons full load. You then have the Type 1936A Narviks, as opposed to their later modifications, and those are 3,600 tons, as opposed to the 100 tons more of the slightly modified versions. Then the Type 1936B destroyers at just over 3,500 tons, and then you have, so those are the biggest ones, and then you have a weird competition for the next slot with a whole bunch of ships coming in at 3,400 tons. So you have the Le Fantastique class of Japanese French ships. Sorry, you have the Battle class 1943 variant from the Royal Navy. You have the Gearings from the US. You have the Shimakaze class from Japan again. Again, all coming in around 3,300 to 3,400 tons. And then you start to see weights drop off to merely the high 2000s. So, yeah, there you go. Biggest destroyers of the war. Cyclic asks, how well do you feel the Tosa class would have stood up against the N3-G3 and the South Dakota classes if the Washington Naval Treaty either wasn't signed or had allowed for the completion of all ships then under construction? Honestly, I don't see them faring very well in battle, to be quite candid. They are outgunned by the South Dakota 1920s by 2 guns, and the South Dakota 1920s are using 12 of the original 16-inch 50 caliber guns. Yes, Tulsa might be able to run away, but that's about the only thing it's got going for it. It's got 2 less 16-inch guns, and the guns are less capable. Again, against the N3, 10 16-inch guns similar to Nagato's versus 9 18-inch guns. You're not winning that gunfight, mate. But again, you can run away. Against the G3s, you have more of a problem because G3 has 9 16-inch guns, Tosa has 10 16-inch guns, but G3 is a hell of a lot faster, so you ain't getting away from it. And even G3, being a battle cruiser, is significantly better armoured than the 11-inch belt on a Tosa, which means the G3, again, despite being a battle cruiser, might actually have a decent immune zone at medium to long ranges. Against a Japanese battleship, that doesn't. And suffice to say, the far more heavily armoured South Dakotas and N3s will have significant immune zones against the Tosa, and the Tosa is not going to have any real effective immune zone with an 11-inch belt against the incoming fire. So, yeah, turning one of them into cargo and then using the other one as a fire experiment was probably the kindest thing you could have done for them. I think the Japanese were somewhat barking up the wrong tree when it came to their 1920s battleship designs, unfortunately. And that brings us to the end of this particular episode of the Drydock. Again, if you are interested in the winners of the competition, or if you want to see if you were the winner of a winner in the competition, please go back to the start of the video and check to see if I read your name out. Contact details at the beginning of the video. Thank you very much, and I hope to see you all again for another video.